Alrighty, hello there. Good evening. I'm sorry about being late a little bit. Still a little under the weather. Late by 2 minutes. Oh my goodness. Sorry about that. And people are probably waiting for me at 9:30, but I thought I would move it up to 9 o'clock. We'll see. Maybe that was a mistake. But we seem to be okay. Well, good evening. If you're watching this in the recording, you're like, what the heck is going on? Well, this is my third live broadcast on Fridays. I moved it from 9:30 to 9 o'clock. I thought some people were having to stay up later, I noticed. So I decided to move it. Let me see how the browser's working. Let's see if I can go to the one article I was looking at today. Go there and see if we can get that up on the screen. How that looks here on the browser. We'll switch to that. And there it is. So that looks pretty good. So Japanese spacecraft snaps incredible close-up of an asteroid. That's pretty cool. And there's that. And I'll be back to me here and see if we do have some people here. Let me turn on my go. I can see that it was announced here. I'm going to turn the volume down. And in fact, we're there. And yes, we are live. Let's put the chat here. This is now live. I see that announcement in a couple of places. So very good. I still don't have the hang of this though. I've got it. It does look like it. I can see it's here when I switch on the screen, but the way it works, it's a little bit mysterious. It seems like I've started on OBS and then I got to move it over and get it started on YouTube, which of course is, but maybe the 9:30 has thrown people off. Why one watching now? Well, hello. Yeah, I moved the time, so I appreciate it. Hello there. I can see now somebody has shown up. We're working on we've got Basecamp working the CNPS and coming some really good realizations for our website Science Woke, and that's something that I've been just thinking quite a lot about. And I was going to make a video on that we're in the middle of paradigm shift, but it turns out that that's an extremely profound idea that if you've read Thomas Kuhn, who sort of invented the paradigm shift, it was the structure of scientific revolutions or something like that. If you've ever watched Thomas Kuhn, or let's see if I can find his book here. Super famous. Actually, he was a physicist and he was a philosopher. Yeah, the structure of scientific revolutions. And reading about that gave me, well, knowing Thomas Kuhn gave me the idea and understanding of why we have people who, so many different types of theories, so many people out there coming up with different models of the universe. I mean, why would that be? Why isn't there only one? That's one of the objections some people have. But it turns out that, in fact, where we are is in the middle of paradigm shift, and this is very common. And actually, in Thomas Kuhn's book, he talks about that. I'm going to look into doing a very well-produced video on that, more than just like me sitting down here, and also we're going to be having that on our Science Woke website. So that's something that we're looking to do. So hello there. Hello there. Who is that? Somebody, maybe it's the guy who's giving me, I get a few thumbs down, but mostly thumbs up. It's pretty cool. So anyways, I'm going to be talking about something when we get a few more people here and hopefully get talking away But again, the structure of scientific revolutions is something. If you are new to being science woke, it is definitely something you want to look into and read. It isn't easy. It's not easy at all to read, but it's quite good. It's quite important to those of us who are looking into the way scientific revolutions happen. This was written in 1961 or 62, I believe. Yeah, 62. The 50th. Well, the 50th would be what? 50 would be 2012. Yeah, 2012 edition. So I guess they have a new edition on 2012, the 50th anniversary of this. He was, I think he went to MIT, if I'm not mistaken. And he also gave examples, the historic examples of chemistry. He looks at the Copernican revolution, which is where, obviously the idea that the Ptolemy's school of thought, you can see this epicycles and cycles, which were really complicated, because if you put the Earth in the middle of everything, of course you're going to have a very difficult and complicated model that you're using. And of course, if you move the model, and you can see here, they have a web page on there, and you can see all the complexities that they were trying to come up with, because they decided having the Earth in the middle made, of course, the planets in the sky do not take the same orbits. They do like S curves, they do vroom vroom like that, and that kind of thing, of course, is a model that they were looking at and accepting until, of course, Kuhn illustrates how the paradigm shift later became possible when Galileo Galilei introduced his idea concerning motion. And so he talks about paradigm shifts. And when I first met Dr. Carasani, I took out all the books I could in the downtown library in Long Beach, where I lived and he lived. And that's why I met him, actually. I never thought of that. We lived in the same town. And his son-in-law happened to come by into his shop. That's an interesting story for those who don't know how I got into this, believe it or not. It's all because my wife's Brazilian and I was living in Long Beach. I was living in Long Beach, and I was in the artificial intelligence group. I think at the time was it McDonnell Douglas I was at, and then I was also at my goodness, TRW, and their artificial intelligence labs. And it turned out that this guy was walking along, I don't know, walking his dog, just taking a walk, and saw the Brazilian flag, and he had this crazy idea of bringing in acai, which is a sort of a berry from Brazil, which wasn't such a crazy idea because now they're really doing that. And he came in and he saw the paintings on the wall, my paintings. Maybe I'll do that too. Maybe I'll go to that website. And he was very surprised because when he saw the paintings on the wall, he says, "Oh, I see you've got an artist in there, and who is that?" And he said, "My wife, who is there, who's Brazilian, and she's a clothes designer. She had her own little shop there." And she said, "Oh no, that's my husband's, but he's not. He's a scientist and an artist." And that was sort of that something that got him interested in me, because he thought, okay, if this guy's an artist and he's also a scientist, then maybe he would be interested in helping out my father-in-law, who showed Einstein wrong, and maybe I'll bring him by. And that's when I met Dr. Carasani. Came by. He was a very skinny guy. He came by Argentina, spoke pretty good English, and I'm going to show you some of my artwork, I guess, while we're doing this, and just to show you, yes, I am an artist. I'll show you a portrait I did live of my wife. It's got some reflection. It's not a great photograph. You can see some striations through like there, and that's because it's through glass, because I have this in a how do you say, it's in a frame, in the glass frame. And the reason I'm off showing my art here is because that's my wife, a life portrait of my wife, is because it's part of the story of how I got into this. In fact, if you watch the movie, my documentary, Einstein Wrong, you'll find out. But this, I had art on the wall, a little bit more of maybe more abstract as well. You can see some of my abstract art here. This is sort of Rio graffiti. It's still very well balanced in the sense of, when you do abstract, when you draw realistically like I do, then your abstracts become very well balanced and all that stuff. And you can see actually computer code in here. So it's sort of like, I can see Rio and the feeling, because I lived in Rio for about 3 years. But anyways, this gentleman came in. Here's one I did of my mother, God rest her soul, and my daughter when she was a baby. You can go and see this at thehilster.com. But it was this art that this guy saw, and he basically came in and said, "Hey, well, I'm going to bring this guy over, and this is my father-in-law," and that's how I met Dr. Carazani. Hey, I see more people coming. Thanks so much to see you. And I'm just telling the story about how I got into dissident science. And so he brought him over, and he said, "Hey, I've got some of these papers," and I showed Einstein Wrong in the 1940s. It turned out he actually did an experiment at SLAC. That's the Stanford Linear Accelerator. So I said, okay, I'll try to help. I had no problem of thinking Einstein was wrong. So it turns out that I'll go to his the website that I made for him. And he came by and plunked a bunch of papers down on my desk. That's him here. Boy, that's another story. These are really interesting stories that I actually don't tell about this kind of broadcast. But there's Dr. Carazani. And there's a whole story just to that photo. But anyways, he plunked down a bunch of papers on my desk, and then I started reading them. I didn't really understand what I was reading exactly, so it took me some time, and he explained it to me, and I still didn't get it, because he talked in mathematics, and he talked in physics, and I'm a visual person, so I was trying, and it took me many years, in fact, to get to the point where I could actually explain what he had found. And I can explain that now quite easily, and I don't credit myself for it, but I do take some credit for helping out and finding what that was all about. And of course, I started the society, and that was back when the internet was barely coming out. I met him in the early 1990s. So 1982, the first browser I saw, because I was in artificial intelligence, we got the browsers back then. It was Mosaic and Netscape, and we saw the first browsers. And I remember seeing this really weird page and laughing at this guy, because he was selling books out of his garage, and he had just a handmade web page, and he was shipping out books from his garage. Bezos and Amazon. But that was the time, and I actually became the third biggest crackpot on the internet early on in 1993. In fact, if you go to sci.physics, the Google groups, or no, they're not Google groups, but they were like the alt groups or something, you'll find that I was listed in the 1994, 1995, 1996, that time frame, as a kook, as the biggest science kook, because I was talking about how the neutrino didn't exist, and they are all on my back. But anyways, I met all that because of my artwork and being a scientist, and then started typing on things on this really old Apple computer. Almost one of the first laptops they had was black and white, and it wasn't even grayscale, only like 6 grayscales or something. And I was typing all of his stuff, and then I ended up putting it on the website. And we got a website and was putting his work there, and that's how I got involved in it. And just recently I've updated, so there's stuff in here that's quite old actually, but it's a great website, and that's how I got into it, basically because of my artwork, and then the guy coming by. And then I spent a bunch of years until I finally figured out what was going on, and I did videos. I got some really old videos that are pretty funny. The production, at those times it was very expensive. Everything was on VHS tape, and editors were doing edit tapes onto another tape. It was just bizarre. But one of the stories I have is that I actually called up Herman Leonard, a very famous photographer who had assisted in photographing Albert Einstein. I said, "You want to photograph the next Albert Einstein?" Because this Ricardo, of course, fixed the special relativity equations. And I actually got him to photograph him. He didn't know much about what was going on, but we both flew out to New Orleans and he photographed. And this is just amazing. There's a couple photographs that they have of him. He's actually 97. I haven't talked to him for a long time. We had sort of a falling out when I made my movie, but it makes me. I'm not disrespectful in any way at all or mad at him, because he's had to fight 60, 70, 80 years, 70 years, the fight against dissident science, working against the mainstream science. He actually did an experiment at Stanford Linear Accelerator. You can actually look it up, and supposedly showed that autodynamics, not his theory, but his equations didn't work. But it turns out that the experiment he developed, and the first one that they ran, it was impossible. It was designed incorrectly. Then he tried to do it again, and then they wouldn't. They sort of closed him out. It's one of those stories that you hear. I'm going to write an article for Science. That was one of the other things I'm going to do on Science Woke, is to write all these stories about people who have been kicked out. Halton, Arp, Dr. William Lucas, Bill Lucas, all kinds of people. So they all, including Karzani. Karzani was also, sort of shut out. Hello, Scar Runner. Hello, world. Hey, I changed my time, so I probably got people who expecting me at 9:30. But I tried to move it earlier instead of later, so we'll see. I appreciate all you guys coming by. Actually, I get a lot of views on this because I think people like the stories and stuff where it's just more of a train of thought than anything. But lots of stories to tell. But I was talking about the structure of scientific revolutions, because I'm going to be writing an article and making a very well-produced, and it may be months, a video on why we're in the middle of a paradigm shift. And Thomas Kuhn actually talks about what the symptoms are, and we're absolutely in that right now. And I thought it was very interesting. I'm going to write an article, a very important article for the Science Woke website. So that's something I will do. But anyways, I appreciate you guys coming, and maybe at 9:30 we're going to pick up some more people, because we have up to 10 people for 2,500 subscribers. That's pretty normal. But let me take a look here at an article. I thought this would be interesting to take a look again how I look at something, and something caught my eye. It would be very, very, most people would go right by it. They would blow right by it. But this is yesterday at 10:02 a.m. So this is a very new article. But Japanese spacecraft snaps incredible close-up of an image of an asteroid. That looks like, well, this could be really close, that I could put my footprint, that this is like a couple meters across. It turns out it isn't, because if you go down here, they sort of put it in the context, and it's like 5 kilometers away. So these are big. It's like probably not mountains, but they're pretty darn big. So this is quite a ways away. So these would be like big hills. But regardless, I always like stuff about space, because I grew up I'm an oldster. I'm an old guy. I grew up with the Apollo program, and when I was a kid, I used to make models of all the spacecraft, like the lunar lander and all that stuff. But if you're reading about this, it talks about returning breathtaking images, and they're talking about from just 6 kilometers away, or 3.72. 1 pixel in this image is around 60 centimeters, or 1.9 feet. So it's hard to tell scale on these things because they're just so bleak and dark. But there is something here that I wanted to point out too. I just read stuff, and when I find it interesting, and I'm coming up to this talk, I'll look at it. But here is, in this paragraph, there's something that's very interesting. I'll read it to you. Hayabusa 2 will eventually try to sample the asteroid's surface. This is not an easy feat. Asteroids have weak, complex gravitational fields, as well as a dusty and rocky surfaces. All this makes landing without bouncing off a formidable challenge, which it does. Here you can see a large crater towards the center of the image, and lots of large rocks. Now, what is the phrase that really caught my eye? This phrase right here. Now, this is something, let's see if I can make this bigger. There, I can. Yeah. So there we go. It says right there, complex gravitational field. Now, why this is so interesting to me is because when we talk about dark matter comes from this idea that the stars on the edge of galaxies go faster than they should. They go at a speed at which they're not really supposed to, according to simple Kepler and Newton. Because why? They make the mass of the galaxy, and they put that right in the middle of the galaxy, and they do their calculations if it's a point mass. Yet here, as they are going around this asteroid, they're looking at a complex gravitational field. Well, man, you talk about a complex gravitational field, take a look at the gravitational field of a galaxy. And when you take a look at it, you're going to find, in one of my videos I talk about this, about how you don't need dark matter, is because that the gravitational field around the galaxy is very different. Where they have the arms and lots of stars, you're going to have more gravitation, and in between you have less gravitation. So what happens is the gravitational field on the edge of a galaxy is much different than if you put the point of all the mass in the middle of it and just treat it as a sphere. And, excuse me, still fighting this cold a little bit. So if you go and you calculate and using Newton's terms, you're going to find out that, in fact, you will do the calculations and find that you can account for the speeds at the edge because the actual field is not, as we say, as they say here. Let me go back to it. Whoops, wrong one. A complex gravitational field. And if you take the complex gravitational field into account, guess what? Everything works. You don't need anything special except Newton and Newton's gravity. You don't need dark matter. You don't need dark energy. So when they talk about complex gravitational fields, I'm thinking to myself, why don't they apply the same idea to galaxies and understand that that will cause the stars on the edge to travel at different speeds than if you made a point mass? Good question. But that blows right by most people. So, excuse me. So I am going to take a look at some other things here. Again, I was talking about Karazani's work. If you haven't seen the dark matter explanations, I believe on Wikipedia, our Wikipedia, wiki.naturalphilosophy.org, I'm going to go and search for Cameron, and that's Rebigsal. And we take a look at this guy. I really like his work. And there's one called Newton's Gravitational Law over Dark Matter. Now, I do talk about this in another video too, but since I've got so many videos now, a lot of times people don't necessarily, how do you say, go back and look at them all. Although one of the things you may want to do is do a search inside my YouTube channel if you have any questions or something. I do see somebody has a comment, and I'll get to that in just a second. So this is Newton's gravitational law over dark matter. I want to point out to you something really interesting here. I'll click on this, and that is this. You see this blue line? That's the velocities of stars. Does that look like anything? Yeah, that looks like the density of the galaxy, where you can see right here, you can see the very dense center, then you get less, then an arm, then less, then an arm, etc. And because of that, he takes it and he actually makes the gravitational fields, the arms, into rectangles, and he starts calculating these rectangles. And you see lots of calculations here. It's not important that you necessarily follow through with that. But then he puts them together, and what is he doing? He's creating a galaxy that is an unbalanced and a complex gravitational field, like we see over here. Sorry, I keep clicking to the wrong place. Complex gravitational field. So here he is. He's simplifying the arms of a galaxy, and he's going to look at the stars on the edge of those arms. He's going to find out that those, in fact, and you can see in this figure 7, it even gets more pronounced, where you can see that these are the arms, and now he's like flailing them out, and he's going to calculate those speeds. And it turns out that looking at this, he's going to figure out and say that, in fact, looking at the complex gravitational fields of galaxies, that in fact Newton, and that's what the title says, Newton's gravitational law over dark matter. So when I read this, I said that same thing. I said, why aren't they doing this? You know why? Because there's no money in that. Because that means we don't have to do anything except some calculations, and we don't have to look for dark matter and spend millions and billions of dollars trying to find that. Okay, let me take a look at some of these questions here. Oi, tudo bem? We've got Protox from Brazil. Tudo bem, cara? Você é cara do Brasil, você é uma pessoa, você é estudante de Andrea Sisto. I'm sorry, talking a little Portuguese there, you know. And let's see if Prototext is actually from Andrea Cis, who is a Brazilian, really Brazilian, a brilliant Brazilian physicist and engineer and professor at one of the big institutions in Brazil, and he actually teaches, instead of Maxwell, which is all relativity all over it, he teaches Ampere and Weber. And I did an interview with him, and I've done many things with him. And of course, he is a person that actually teaches an older theory about electromagnetism that he believes is correct, and he believes that Maxwell is not. So, John Otter, have you examined the arguments posted by Dr. Pierre Robertel regarding the nature of the matter of the sun and stars? Oh yeah, I have seen him. I was very impressed just by the idea that my hair, I didn't comb it. Just the idea that he was having, and he had Stephen Crothers on here. Stephen Crothers is a favorite person of mine. I've met him several times when he came to our conferences a long time ago. And yeah, I have seen that. I haven't looked at his sun stuff because that's sort of not an area that I looked into very much. But I certainly am a person that is absolutely open to what we think and is happening in the universe isn't really what's happening, because we don't even believe in mainstream science that the Earth is expanding, and it is. The data is overwhelming. 99%, in my opinion, the data points to that. So yeah, I haven't looked at him. In fact, you may want to suggest to him, John Otter, say, hey, maybe I can do something with him. I'd love to do something with him. Maybe I'll even ask to see if he'll be interviewed. That would be really great. I do interviews on my channel, so absolutely. He's got a lot of followers. He's got more than me. So he's doing, but he does a more mainstream idea, and so as people are, the sun and all that, even though his ideas do go against mainstream, it's not so controversial as if when you attacked Einstein, the god. Stephen Crothers, yep, is also an person. He does a lot of advanced stuff, so I'm trying to understand it, but he has great videos in Sky Scholar. Yeah, in fact, I saw those recently. Basically, Stephen Crothers' claim to fame is, yeah, John, that would be great. Again, I'm very aware. Oh, that's right. Yes, I actually found you by Jose Assis. Very good, but I was not his student. Oh, wow. Okay. Well, thank you for coming. Muito obrigado, Protox. Yeah, minha mulher é brasileira, eu falo português com sotaque carioca. Você da onde, Protox? Okay, just a little bit of Portuguese. Ask my friend, where's he from? And John Otter suggests that. Let me tell you a little bit about Stephen Crothers, the things that stick out in my mind, and I've seen him talk with several times. Two things that are interesting, and I'm going to write these down because I always say two things and then I never remember what those two things, and I'm already forgetting what those two things are. Okay, I got that. And of course, there we go. Wrote it down. So, two things about Stephen Crothers. First of all, before I even say anything about Stephen Crothers, I will say that what his claim to fame is that he has a great story. We're going to put him on Science Woke as one of the featured scientists. But he actually was kicked out because he wanted to write papers against the black holes, and that the mathematics for black holes was full of problems. I mean, not a few problems, not a few minor problems, but absolutely major problems, step after step at the Schwarzkopf or something like that. Please do not Schwartz something the equations. I have looked at them. I have a degree in advanced calculus, bachelor's degree, so I did take a look at it, and it was understandable. But the thing that was interesting is that there's many steps in the derivation of the black hole equations. And it's just wrought with problems. I mean, just wrought with problems. Many of them subtle, but one of them that really stuck out to me, and that's what I want to talk to you about. And I think that's the easiest to explain to a layman who doesn't really understand necessarily about all the complicated mathematics with Stephen Crothers, is that in the middle of the derivation for black holes, all of a sudden, two masses appear. Instead of one, two masses. Now, if you think about it, you really have no reason to introduce another mass in black holes, because black hole and its calculations all have to do with one mass. One mass. There's not another mass in there. So if you're doing a calculation for a black hole, which is one mass, it'd be sort of like saying, I'm going to do calculations for the gravity on Earth or on Mars or something like that. You don't have another mass in the equations of stuff. If you look at the acceleration for gravity for the Earth, you have something that is not, it only has one, has one mass in it. Well, the gravitational has two masses, the force does. But in the calculations for black holes, you're going along with one mass, and there's no reason for another mass, and all of a sudden you get it. They're not calculating the gravitational force of a black hole. They're just talking about black holes themselves. So that's one of the big things. He just stops in the middle of his talk and just says, where did this mass come from? Why did they introduce it? And so there's a real problem there. The second thing is that it was interesting. He wasn't really too much into Einstein being wrong. And when I had talked to him about that, he sort of balked at it. He's almost like believed that Einstein was correct, I think, in the beginning of his career. And then he started looking into it as a critical thinker. And this is a great lesson for every one of you. And that is, I told my daughter that Einstein's wrong. Now she's getting to the age where her friends around her at 12 years old, she's in the 8th grade, are starting to say, your father's a little crazy. Of course Einstein's right. Why would he know he's wrong and no one else would? I mean, that's what people are going to say. But they don't go and look at it. My daughter doesn't go and investigate it. But what happens with these people, Electric Universe and Stephen Crothers, they eventually, probably 10, 15 years ago, they were laughing at us who were saying Einstein's wrong, sort of behind their backs and saying, meh. And it turns out that, in fact, they started looking at it. And guess what happened? Stephen Crothers now talks about how relativity is wrong. He came around. He came around, even though we literally have thousands of papers and hundreds of books that have been written on the subject of Einstein wrong. He has come around. Now he's become a prophet or a evangelist for the idea that relativity is not good things or screwed up. So that's what I know about Stephen Crothers. And yes, I did see his stuff on the Sky Scholar, and I think he worked with them. I think he got a green screen and all that stuff. A green screen is put a green background behind it. I have one. I've used it before, and sort of did a nice production. So I think the Sky Scholar or Pierre Robitaille, helped him with the production. So I'd love to do a series on him or have him just interview him. So yeah, John Otter, that'd be cool. And our Brazilian, he's from Goiânia, Goiás. Man, you know how many people from Goiânia, Goiás, I know here in Florida? A ton. There are, for those of you who do not know, there are 500,000 Brazilians. They say 300. There are more than that here. So 500,000 Brazilians, and many from Goiás. And I have actually some very good friends from there. And the experiment kit. Where is it over here? Here it is. This is the experiment kit that I got. And if you don't know what that's all about, I got this from Andreas Cis, and I owe him on that. But see right here, and from Brazil, And I have a whole unboxing, so you got to watch that one. That is so cool. And he sent. This isn't it. This is some old videos someone sent me. You can see my back here. It's like the crazy scientist. Oh, see, I'm using Einstein's. Oh, here it is. And the guy from Brazil saying, Dave, that's not from Brazil. Cara, essa não é do Brasil. Essa é do Brasil, gente. Correios. Claro, é do Brasil. Aquela caixa que você recebe. It says right here, David D. Hilster. And I did an unboxing. Absolutely go and watch it. I've got all kinds of stuff here. Ooh, look at that. Let me see if I can get something that's pretty cool and show you. I've already done this in the unboxing. Oh, yes. Oh, this is pretty cool. Look at this. What is all this? Well, all this stuff in here is for, oops, look, some string. I can't, you got to be careful because it's all sort of attached. And I'm going to go through and I'm going to do these experiments. And that's what I actually should do, because look at this. This is like a little cup. It's got like, you know, plaster in it. I don't know how to call that in Portuguese. And I've got these little, those push pins that we got when you were a kid and you made those things. But it's all got all kinds of stuff. And it's got like a little guy in here too. I call him a goleiro. You know, because Brazil lost. Oh, what's that all about, Proto X? My goodness, I can't take him out because he's buried in there. The guy looks like Brazilian, looks like a goalie. Maybe they could have used him in the World Cup. But what that's going to do is I'm going to do his experiments. Excuse me. But I will tell you, those experiments are extremely simple. But guess what? The hardest things in physics and cosmology are the simplest in how to explain them. Cimento, that's it. It's like biscoito in Portuguese. Biscuit, like biscoito in Portuguese, you know what that means? It means like cookie. It means like any crackers, anything like just a small thing that you sort of eat. So, or biscuit. So it means biscuit, cracker, cookie. And now he's telling me that the plaster of Paris, or plaster, is cimento, which is also cement, of course. But that's okay. Brazil's actually, Portuguese is one of the hard languages. It's one of the 5 Latin languages. Can you name the 5 Latin languages? Most people can name 4 of them. And I'll tell you the one you always forget. Latin languages: Spanish, Portuguese, very good. Italian, of course, easy. French, what's the 5th one? Romanian. That's what you get when you are talking to a person who has a master's in linguistics. So, anyways, I can fool Brazilians for a few minutes. When I'm tired, I don't speak as well, but I've been speaking Portuguese probably almost 40 years. But anyways, Robitai, thank you, John Otter. Robitai, Sky Scholar, Cimento. Alrighty. Hey, got 6 people watching. If you have any questions, just ask me, and I will go and I will do something, or ask Pierre Robitai. Thank you. But let's do something. I did see him, and I was thinking about that. I want to get to see his subscribers see what I'm doing, and my subscribers see his stuff. It's really great. It's more specific, but he seems to be open-minded. He had Stephen Crothers talking about things out there. Okay, let's see if I can go to a website here. I'm not sure I showed you this again last time, but since I have new people, so wait, let me read. I'm waiting for it to come here. Let me read Goyas. I'm looking for the experiment. Okay, that's what he said. It says, I'm wondering how to get balanced view on both sides. I can't look at only mainstream stuff, but I think you can't look at dissidents only. That's how you discover new stuff. That's a very good question, Scar Runner. Well, guess what? The answer is we do. Now let me tell you how I know we do. In fact, Scar Runner, I will tell you that we know it better. I'll give you a perfect example, and we'll go take a look at that person. I will show you a picture. Oh, I got rid of that. Let me see. Just bear with me. I'm going to show you a picture of a person who knows something about the mainstream science better than anybody, probably, in my opinion. And that's Dr. Riccardo Carasani. And what does he know? He knows relativity better than mainstream. Why? Because he studied the heck out of it. He studied the origin of the neutrino more than anybody. And because of that, that's where he was a critical thinker, and that's why he found the mistakes. So the answer to your question, why you need to have a balance, of course, have a balanced look at things. Well, almost everybody I know who has, this is a misnomer, this is a misconception of people who are in the dissident world like myself. Like we have our own model, for instance. Our own model, people are going to say, oh, you just threw everything out, you didn't study anything, and therefore, and you just made it up. So what good is that? Anybody can do that. That's absolutely not true. We studied mainstream stuff and what went wrong with it. Why gravity, the equations are so primitive, because gravity equations they use, even in NASA, are pretty much point masses. They don't put any type of gravitational field that's complex at all. So the answer to the question that's how you discover new stuff, you're exactly right. And almost every dissident, without failure, has looked at mainstream more closely than mainstream. Because why? Because if mainstream looked at relativity closely, they would find that, yes, there are problems, and those problems are insoluble, that they're paradoxical. And in fact, Carasani finds that, and Carasani states, what did Carasani find wrong with special relativity? I've said this before, but that's okay. I've got 6 people watching. I appreciate you guys being here, because like I said, I've got a lot of people who view this afterwards, because not everybody can make a live showing here. And basically, no problem, Lisa. I figured I even started early for you, Lisa. No problem. But I was getting back to the question of how do you discover new stuff? Well, you discover new stuff by looking very closely at it. So Carasani took a look at special relativity, and when they were looking at this is how he got into it. This is why I'm here today, because Carasani got into it because when they talked about radiation, get my famous globe out here. Here's radiation. Well, what's radiation? This is sitting here. There's nothing provoking it, and the atomic structure is unstable. Because the atomic structure is unstable, electrons are streaming out of this, and they go as fast as 0.86 the speed of light. Now, if that's the case in decay or radioactivity, at the time in the early 1900s, people were looking at that, excuse me, and they were finding out that if you were looking at special relativity, that these high speeds of electrons, that if you applied the kinetic energy equations to these electrons, you should have more energy than that's coming out, even though they measured exactly the same thing. I'm sorry if I bored you with this a number of times. But that's what Carasani found. And the first thing he saw was that they're applying kinetic energy equations to radioactivity, which does not have kinetic. Kinetic energy is like this. Here's a system, and I'm pushing it. That's kinetic energy. Radioactivity doesn't have that. I'm going to go get a throat lozenge. I think I have one more because I'm going to cough, and that's terrible. I will be right back in a second. Where is it? Oh, hold on. I'm here. I'm going back. I'm on my way. You can hear me. And I've got one left. Thank goodness. Sorry about that. So, what did Carasani find? He looked at the neutrino and how it was postulated. And that, I can just stay there. I won't even talk about the relativity part. But what he did is he reconstructed what Pauli was doing, which is applying, he was using kinetic energies equations on something they shouldn't. Carasani got in an argument that was watched by all the students in Argentina at the university between Carasani and the professor, and they were going at it. And what was he saying? He says, Professor, there is no logic in applying kinetic energy equations to radioactivity. You don't have to be a rocket scientist. You don't even have to understand the equation of what kinetic energy is. It didn't matter. They still applied it, and when they applied it, of course, they're going to get more energy because it's that magical thing is you get closer to the speed of light. You have to have more energy, more mass. Because of that, they invented the neutrino. So, Karazani ended up finding out that he also found an error in the special relativity equations. It wasn't an error, it was just a redundancy that they can be simplified. And when you simplify it, they turn into Newtonian equations. And actually, you can describe particle accelerations and collisions without the neutrino because you don't have the extra energy. So you don't need it. And that's pretty interesting. So, to answer Scar Runner, is the answer to the question of, well, you guys got your stuff, and I'm not saying you're doing this, Scar Runner, but this is what you hear. Well, you guys expect us to look at your dissident stuff that says it's wrong. Have you looked at our stuff? Yeah. That's why we became dissidents. We looked at it, and we found problems. So that hopefully answers your question. Have you seen the manga guide to relativity I posted? I think I have. I don't remember it. Maybe if you can put a link there to it, I'll take a look at it. Hi, Lisa. Be right back. Go to look at the moon. Oh, where are you, Lisa? I want to know where Lisa is. She must be somewhere else in the world because the moon isn't out right now. In fact, I can look at the moon. I can get out my. Where's the moon? Is it going to come up? No, I think the moon's on the other side of the Earth. So I've got this app, and it will show me where everything is. All I have to do is point it around, and I will see here where the moon is. But she must be where the moon is. Anybody around where the moon? Did they see the moon eclipse? Okay, there we go. That's the sun. The moon is. Oh, there's the Milky Way. Oh, that's Jupiter. Yeah, moon's not around up on our side. Since you are a programmer, you must find logical problems in special relativity. How can you define the light speed as constant before even defining what speed actually is? If you get into the semantics of what speed is and the speed of light and all that stuff, it turns out that I don't think that's as interesting as the problems that you actually can find in special relativity. And there are a couple good ones. In fact, if you go to naturalphilosophy.org, if you go to youtube.naturalphilosophy.org, go to our website for the CMPS, take a look at the second most viewed video. And that's my father talking about, it was funny, my father was going 10 years like, Dad, you're in a movie, you're a star in my film, and it called Einstein wrong, and you don't even have an opinion on it. I've never looked at it, so I don't know, you could be wrong, you could be right. Then all of a sudden I see him giving a paper, and now his explanation is a really wonderful explanation. So if you want to look at logical problems in special relativity, there's quite a few. What I would recommend Proto-X is to go... Proto-X, I get it. Jeez, I'm so stupid. Your English is very good, by the way. Parabéns, você fala inglês muito bem. Talvez você é americano, brasileiro. All right, but anyways, I would recommend you take a look at that video by my father, youtube.naturalphilosophy.org. Go there. And, you're in Pennsylvania. It's totally there, and it's totally there. Oh, so maybe it's outside. But is it like eclipse right now? They said it'd be over at 5:30. Or maybe it goes, I don't know. I'll have to see. Let me see. Okay. All right. I'll be right back here. Where are you? I'm in Florida. Okay. Where's the moon? I can search for the moon. Sets in 9 hours. Oh, it's out there. Oh, it's over there. Oh, there it would be on the horizon right out there. Oh, I could actually put a camera on it and take a look at it. So, anyways. I'm here. Okay. John Otter, where are you located? I'll say, John, no judge. My instantaneous velocity was 150 miles an hour, but I stopped at all the lights, so my speed was actually 30 miles an hour. Very good. Instantaneous speed in velocity. Can you drop the links to these other channels in this area? Oh yeah, absolutely. What, I'm a dummy, huh? In fact, I'll go to the one video I think you can watch. It's very good. I was really surprised. My dad actually contacted me and said, "Oh, Dave, by the way, let me go to that one. I'll just go to my browser and you can follow along." He goes, "By the way, Dave, my video on CMPS got over 1,000 views." And I thought, what? Get out of here. Because I'm supposed to be the guy who knows all about, I'm the famous. I'm kidding, of course, folks. I'm kidding. I mean, you want to be famous, you certainly don't want to do what I'm doing. Anyways, I was joking with him. Wait, I'm the guy I made the film. And he said, nope. Right. Let's see. Yep, right here. Popular uploads. 3.5 is something I did on the Higgs fake. He's probably wondering, Dave, you promised now I'm ready. I can do interviews. Right here. Special relativity is not needed. Actually, I think I can click on that. I don't know if it's going to come out. I have it muted. So, anyways, this is the one, and he's talking about it. Anyways, I don't know. Are you hearing that? Probably. No. No, I don't think you are hearing it because I have it. Do I have it muted? Yeah, I do.
Been working on gravity for 10 years in response to David asking me to help with a gravity experiment. And during that time, I realized if I was ever going to get anything done in gravity, maybe I shouldn't be paying attention to trying to prove somebody wrong. And so I kept telling David, halfway through the film, he said, "Dad, you never say Einstein's wrong." And I said, "Dave, I haven't taken the time to prove it." And so he was very frustrated with me, and I didn't, even until last year, when I found an article by Robert Johnston, and let me give you a little background. Anyway, this is...
Okay. Anyways, want to take a look at that. It's pretty interesting. So I'll get back to the questions. But yeah, that's something you want to take a look at. Go look east, young man. Yeah, it's out there. I should probably go out and take a look at it. You know what the problem here in Florida is? I'm actually on the second story right over here. Hold on. I'll be right back. I'm going to look out here. No, I can't see it. It's over there, though. I'll definitely try to look at it, but it'll probably be over. Is the eclipse over already? Anyways. Big and orange. I just subbed over there. Thanks. I must go out and look at the moon, but I will return. Talk too much anyways. I talk too much. No, you don't. Anyways, that's something. If going back to what was being said here, let me get back here, make sure I know what's going on. YouTube, there we at. Okay, and I will put this down there. Okay, we got 5 people still watching because make sure there's. Appreciate again you guys coming. Let me look down here. Okay, there we go. Got it down. Let me go back up and. All right, I'm just looking backwards. Sorry about that. Just coming over the frames. Okay, we're talking about that. But I understood my limit capacity at the speed of light would be constant. Let me talk about. You look at my father's. I won't tell you what it's about, so you can take a look at it for yourself. It's quite good, and it's pretty easy to understand. So, anyways, I would say. again, take a look. And there's actually a good discussion that goes on with it. But Karazani, if you look at the logical part of it, first of all, the neutrino comes from applying kinetic energy equation to something that has no kinetic energy at all. Radioactivity is unstable stuff, so all the movement comes from within, and it's just basically launching stuff out. That's not kinetic energy. That's decay or radioactivity. Therefore, they are not, how do you say, no neutrino. Second, what Karazani found with special relativity, and I've talked about this again, but we get different people on this, and it's not bad to repeat because sometimes you hear it a couple times, you don't understand it. But basically, what Karazani does, and you go through go through the derivation. Let's see if I can find that here. Just when, of course, I decide I'm going to not have his stuff there, I'm going to change it. I go right back to it. But let's go back to Karazani's. I'll go to the website and Autodynamics, and one page. Let's see. Oh, that's not good. The derivation. Where's the derivation? Galilean derivation, frames derivation, Galilean simplification. Hold on here. Okay. Alrighty. Okay, so this is what Karazani is going to look at. I'm going to show you now. First to get there. So basically, I'm going to increase this. Hopefully, it will get bigger. There we go. Alrighty. So this is what special relativity is completely based upon, and that is two-frame system. You have F and F prime. You have a point P. It's moving at velocity V according to this other frame. So here's the Einstein, and he's on a train, and that train is going by you at speed V. You are here. You measure his distance. He has a velocity. And then all the calculations for everything, you calculate a transformation from this frame, F, to F prime. And you go through the velocities and all that stuff, force, and he goes through these equations, and he finds mistakes in it. One of the mistakes is there's a 3/2 that appears. Again, I'm not going to get into it. I'm going to tell you a simpler answer, but those of you who want to read the math, because once again, the simplification has no physical sense. There's no reason for setting these two velocities equal. So one of the things he finds is that there's velocities that are being set equal in these calculations. And when you set them equal, of course, you can simplify them. And when you simplify them, and here's the velocity. If you see right here, you have a Vx and you have a V. Those are not the same. Let's go up to the, you have a Vx and you have a V. Now you say those are the same, but the thing is, this is a movement of a full frame. This is the movement of this. Well, yes, of course they seem to be the same. But when you're looking at inertial frames and those things are different, the V's, they are set the same. And this makes no physical sense. There's no reason for setting these two velocities equal. To confound the matter, the exponent is 2/3 in the equation does not end up matching the 1/2 in the Lorentz equations. So what happens is when they make this simplification, they call it the sup V's. And I'm going to tell you what and this does, okay, let me tell you what is hard to understand here, but it's not that hard. Here you have V, and here you have V you have the V, and then you have X prime. So V is this X, you can calculate the velocity here. Well, setting those two V's the same, they are the same. But it's the problem is that you are coming from two different ones here in the equations, yet you set them the same. And that is a paradox. That doesn't make sense. Again, this is something you have to look at. I'm not going to be able to explain it to you. The other thing is too, he's saying that in fact, if you go through the derivation, you come up with a 3/2, yet Lorentz has 1/2. This is the reason is because Albert Einstein says he could derive the Lorentz equations without ether using its special relativity. which is false. So these are the things that Karazani said. And then AD, what happens is instead of two coordinate systems and another coordinate system here, and then writing a transformation between these two coordinate systems, that's stupid. Here's a point, and it's moving according to this. You do not need an entire system. And that when you introduce that entire system, you introduce a transformation, the Lorentz transformations, which are artificial, that give you things like, as you get closer to the speed of light, your mass increases, your length contracts, and your time slows down. Why? Because you have a transformation, because you say the physics in this frame has to all be the same, the physics in this has to be all the same. So if light is traveling in this frame at the speed of c, I've got to measure it at the speed of c. Oh, and if I'm here and the light on the moving train is moving, and then I've got to measure at c, then everything has to change. That's a paradox, because Einstein says all the physics here is the same, all the physics here is the same. Then why do the transformations tell you that it isn't the same, that this mass will increase over here and this won't? And then worse than that is, why is this mass increasing and not this mass increasing? Why are your mass increasing while you're watching the train go by? All this is caused because you have two frames. You go down here, you're going to see what autodynamics, what we call AD, autodynamics does and talks about. It says, here's your observer, and here's your observer A. He's moving at this velocity. And there's the light source. It's not the light source moving. There's an observer moving to that light source. Because, as my dad says in his video, once the light goes, it goes. It doesn't care where it was. And not only that, if you have a model of light and it's moving, and if this is a GPS satellite, guess what they do in GPS satellites? They add the velocity to the speed of light. So, let me go back here and take a look at any of the questions. So what happens is you get this problem. I'm going to go back, just checking the chat. You have this problem that this is really what's happening, that when you're on the ground and there's a satellite and it does light signals, and let's say this light source is moving, the satellite is moving, and it's sending radio signals, which is at the speed of light, which is the same as radio signals, the same as light. Then you're going to have actually c minus v, because you're moving away. And then when it's going the other way, you have c plus v. And guess what the GPS scientists say? This doesn't violate special relativity. You know why? Because it averages out to c. C plus v is one way, and then c minus v, it comes back, and it all comes back to c. Because if you add v to c, now you're going faster than the speed of light. But oh, wait a minute, we're going to take it away, because on the trip back, the signal on the trip back, it's the opposite. So it all averages to c, and we skirt the paradox. We skirt blowing up special relativity for good. But of course, Stanford Linear Accelerator, in my movie, he says, we have to teach special relativity to our scientists, our students. So when Karazani figures it out, does the math for this, he comes up with the autodynamic velocity equation, the autodynamic force equation, and at c it does not blow up. So there you go. Anyways, what goes on is AD kinetic energy, the energy is the same. There's also there's a Galilean derivation that he does. So he does two derivations. And this one gets really good. F prime, and F prime prime. This is the Galilean derivations. And he'll go through here, and then they set V prime to V, which is useless and inoperative, and that's what he found. So this is answering, I guess I can put this up here so everybody can see this. This is answering Proto-X's question. I'm not sure he's here anymore, but he may be. I'm hoping he's listening in. So anyways, that gives us an idea of what's going on. See, I had a story name, too many clouds. Yeah. Of course, this is Florida. We have rain all the time. Moon is stunning right now. I promise I will watch the whole show later. Don't worry, of course. Scar Runner had a lot of rain about an hour ago, so that's why I'm amazed that I can see the moon. That is super. I'm glad you can see it. I'll have to go out and check it later on too. Hello, I just dropped this live link in my Science Unsettled Facebook group. Okay, thank you very much. Jesse, thank you. Oh, it's nice to meet you. I really enjoy reading stuff on your Unsettled Science. So, absolutely, I got 8 people watching now. That's very good. On the percentages of people, for instance, you got to have about, let's say, if you have 100,000 subscribers, you're going to get, no, let's see, 10,000 subscribers, you get about 40 people that will be attending live stuff. If you get 100,000, you get hundreds. Right now, I'm at 2,500 and growing at 2 or 3 a day. In fact, I was making a video. I have one on acceleration that I made the other day, and I didn't like it. I wasn't enthusiastic enough, even though it's a really cool video on what acceleration really is at the bottom physical length. So anyways, that was one of the questions I got was, about what, looking at both sides of the equation and all that. Lisa, aren't you supposed to be out watching the moon? That sounds like a good group. I'm avoiding Facebook for a bit, though, because I checked at some point. 10 watching now. Yeah, all right. Absolutely. Thank you, Jesse. If you guys have any questions for me, I'm David D. Hilster, of course. I am actually one of the directors of the John Chappell Natural Philosophy Alliance. No, Society. Was used to be the Natural Philosophy Alliance. And we are a group of scientists who are critical thinkers, who write very serious papers and do serious work, criticizing and then coming up with new ideas. Like I always say, we found errors in mainstream physics and cosmology. We've corrected them and are coming up with new models. So it's really great. My goal is not to tell you what truth is to point you to flaws in mainstream and other new models, because we are in a paradigm shift, and I will be doing something on that paradigm shift. I don't want to do just a regular video on that. Can a person perch an expanding Earth model? They do make such, that's actually, there is an expanding Earth software that Stephen Hurl, the guy who's a dinosaur. So if you haven't read Stephen Hurl's book, Dinosaurs and Expanding Earth, you must. He also has a group. Let's see if I can find it. I'll go offline here real quick because I don't like to show necessarily everything that's going on here because I want to get to it. But let me go see and look here. Expanding Earth. I think he has a Facebook channel, Facebook page for Expanding Earth software. Hold on, I'm going to be trying to find that because I don't want to, again. But the idea is he has actually software that's, it ends up being 2D, but I think he uses Google Earth and he plots that stuff. But yeah, one of the things I wanted to do always myself was to like, hey, can we make software for this? Plate tectonics and expanding software. No, I don't seeing that. Dinosaurs expanding Earth. Let me see again if I can find what that is. Maybe, oh, wait a minute. I think it's in DinoX. Oh, wait, expansiontectonics.com. Let me see if that's where it is. I'm going to go to this anyways. There is, Stephen Hurl has something, but if you go to here, data modeling, it's pretty cool. And they actually have, I'm going to bring this up here. Oh, I can't see that, so let's see if I can get another web browser up here and show you window capture. Oh, there it is. There it is. Okay, so if you look at this, you can do the Cambrian period, and you can start, let's see. I think it's starting, it's wanting to animate, it's just taking some time. But what this is, believe it or not, is not software. This is all pictures of models he drew on these balls, believe it or not. And it's not in 3D, but what you can do is you can pick the, you can pick larger, let's see. Oh, I see. All right, and this will eventually animate, but it'll go and it will turn. Oh wait, this doesn't turn around, but this shows you the different Cambrian period. So I believe if I come over here and yeah, there we go. You can see that. Look at that. Is that cool or what? So you can basically go down this, and you can see all the way the expanding Earth goes, and you can watch it. This is the most. Now let me tell you the difference between this and Neil Adams stuff. Neil Adams did it by just graphics, and it was very good. This is a little different because he also looks at the lakes. Neil Adams does not do anything with the ocean and the water levels. You notice here, for instance, you've got Africa, and it actually has lakes in it. That is a little different from what you're going to see. Here's one. There we go. This is in the early Jurassic epoch. You notice that here, there's a lake there in the middle of Australia. Now, when you look at Neil Adams stuff, he doesn't have that. So again, I'm not cutting on Neil Adams at all because he does very entertaining stuff. But this is more true to the geology. So if you watch this, I can just go down this over and over and look at, the United States, for instance. Look at here's one. Look at, you can see that there's lakes there. So it wasn't the case that the water just filled up exactly, because that's one of the questions. Oh, Dave, if you believe expanding Earth, how was it that the water fills up exactly to keep the continents? Well, the continents stayed around, but the water levels were different here, and you can see it in that they were shallow lakes. And this is something. Oh, there's another one. You see, here's buried. All Mexico is buried, basically, most of it, and is underwater, shallow seas. And you hear Neil Adams talking about shallow seas. So, and you can see it get down, down, down. And he goes farther than Neil Adams because he goes beyond. And I asked him, how can you go beyond? Because once the crust is there and all the continents crack up, then that's where it started, right? No. He goes way beyond that. And I said, how do you know? He says, you look at the geology on top of the continents, and you then assume and you see that on the continents themselves, they were also built up, that the parts around them were built up. So that it is just absolutely, look how small that is compared to the bigger. Look at that. That's what the Earth was. Again, the data is overwhelming. If you don't believe me, study it. So this is one of the things in models. You can't buy them. No, and that was the original question, I think, right? Let me hide this. I'm starting to know how to do this a little bit. Let me hide it. There you go. So that was a question. Can you plunk the link here? Oh, yeah. There we go. I'll put this expansion tectonics dot, is it org? There we go. All right, let's take a look at some more questions here. I did watch Jesse Kowalski. Any explanation why? Oh, wait a minute. Let's see. Did you see Rosenthal Scholar video today got pulled down right after he published it? Really? Well, maybe he didn't like it himself. I don't know. Is this some type of idea? I'm not sure who is Jesse. I don't know what that means. Maybe he pulled it down. A lot of times I'll pull down something if I don't like it. It happens rarely. NASA scientists saying that the 1990 eclipse did not. Jesse, I will talk to you about that. Nature in 2007 or 2008. I will look it up right now. I'll go offline here. Look it up. Nature published that the data was not valid. Nature magazine 1919 eclipse data. Let's see here. Okay, I'm going to look this up. Trying to find it. I will try to find it. I'm not finding it right away. Maybe they've taken it down. Maybe they have. But Nature did come out with an article that, if I remember, it was Nature that said, in fact, that the data was suspect, and they were admitting that it was cherry-picked, the data. It definitely was. So, of course, Infinite Energy says it's the greatest hoax of the 20th century, which is true. 90 years on, Oxford Journals claim that the Eddington dispensed with some of this solar data without good. Okay, I'm going to read that one and see if that's got something in it. But I do know that that's not such a big controversy. At least it wasn't 10 years ago. Now, maybe they've, because there are so many of us, like you guys and me, out there, that they're starting to get nervous. Let's see. The first experimental observation confirmed. Okay, I'll take let you look at here. This is from the News and Reviews in Astronomy and Okay, was carried out in the travel to Príncipe, small island off West Africa, and then a Sobral, Brazil, from the eclipse, and it was be visible this year. An expectation organized to return to Príncipe to celebrate the week. Oh yeah, well, okay. Poor weather, they said. Eddington's. Well, I did see something when I searched on this that they said is claimed that the Eddington dispensed. Okay, so let's go forward. It is dispensed. I'll look for dispensed. Okay. It has been claimed that Eddington dispensed with some of the Sobral data without good reason. However, the Sobral plates were out of focus, leading to great uncertainty on the plate solution. An independent Sobral telescope with a 4-inch lens gave a diffraction of the consistent with the diffraction observed at Príncipe. It was in fact Dyson who initially rejected the results from the Sobral astrograph, not Eddington. In 1979, a reanalysis of Sobral plates using modern equipment measured deflection of Deflection was the first satisfactory confirmation. So what they're saying, yeah, oh wow, yeah. So this is okay. Okay. But regardless, they're trying to backpedal, because I did see something in Nature, and I have seen that pulled out before, but whether or not that's actually the reason it was pulled, I don't know. I don't think so. I don't believe that's true, because I say things all the time that are, Einstein's wrong, Einstein's wrong, Einstein's wrong, the Big Bang's wrong, particle physics, throw it out to 1930. They've never pulled anything. Sometimes, I don't know. I'm not believing it. All right, let's keep going. I did watch, but NASA scientists saying that. NASA scientists saying. Okay. Well, we have a NASA scientist saying that gravity doesn't bend light, that actually mass does. The Sky Scholar vid was pulled. Can stars bend light? General relativity. Oh, Edward Dowdy. Of course, he's in my film. Yep. Wall is excellent. I just heard last week that a live gig here. I was already okay. I think the Electric Universe. Now, one of the things about the Electric Universe, I applaud everything they do. I think there's a lot of good work they do. Whether or not, of course, the universe is electric, there's a lot of electric stuff going on it. But if that's the main thing of the universe, that's what their claim is. And they have absolutely the right to claim that. And again, they have some really good predictions. I personally disagree with some of that stuff, but I do not make fun of any of that and say that that can be wrong. I know they talk about scarring on the Earth or on other planets like the Grand Canyon. I'm more of the expansion tectonics kind of person that says the reason that's happening because the Earth's expanding. And but again, that's their absolute right, and I totally applaud them for them creating critical thinkers, and they're actually going after Einstein where they used to not go after Einstein. They used to sort of laugh at us about 10 years ago. But guess what? Wall is now talking about Einstein being wrong and why it's wrong, and he's giving reasons. What he says is gravity is part of the electrical system. And we actually say in our model that everything is Newtonian, so there's no anything electric it can explain by Newtonian mechanics, and we can explain electrical fields and magnetic fields and all those things. But I am a super big supporter of them, because we have to, in science, allow everybody who is doing good work and has good basis for what they're doing and scholarly work, whether we agree with it or not, I support them wholeheartedly. So I support anybody going there and reading up and joining their group. I personally, like I said, I have different ideas about the model. There's this more, our group incorporates people who are electric universe people, incorporates people who are like ourselves, Newtonian or gravitational people, supports people who are lattice people, all those things. So we're a little bit broader scope, where they are concentrated on those people who look at the model as everything being electric. My biggest question to them is, what is that? What is electric field? What is charge? Because we don't need that in our model. Things attract, not because there's pluses and minuses charge, but because they Newtonian forces of pushing. But again, that's okay. I'm very supportive of what they do. I've heard you believe in eternal infinite universe. What is your opinion about entropy, heat death of the universe? Okay, that's a question from ProtoX. Again, I'm sorry, I'm trying to follow those. That's pretty easy for me. There is no death of the universe, because there was no birth of the universe. The universe has been here forever. It doesn't mean it doesn't go through cycles. The Big Bang is not a cycle, because the Big Bang is based on redshift, and there are actually a number of papers that just came out. One of them this year was by Raymond Gallucci, who looks at just the astronomical vision of galaxies and says, guess what, folks? The distribution does not add up to an expansion. It looks just like an even distribution. So the whole idea that the Big Bang happened, there's a lot of data that doesn't show that. They sort of ignore that. And so I believe that the universe has been here forever. It's infinitely big. It's infinitely big up and infinitely big down, so that inside of this there's just infinite amounts of things, that there's no smallest particle, because if you do have a smallest particle, that particle has to be magic, that kind of thing. So that's my take. So the entropy heat death of the universe is to say that it has a birth and life's death cycle, and I don't really believe that. It's both, Dave, expanding and electric. Oh, there's electric parts, absolutely. The electric field is, in our model, G1 part. Electric, gravity, light, and the electric fields, all of them are the same particle. And electric fields are just moving particles, so that they'll give you in electronic components. So my dad's an electrical engineer, and we're going to be writing a course on how all the components in electrical engineering, from diodes to resistors to capacitors to batteries, all are explained by particles, and that actually the G1 particle, or what we call the electron, or what we call the graviton, or what we call the light particle, well, light's more than one particle, they're all the same particle, and that the electric is all explained by moving particles. That's in our model. So that's what I believe personally. Let's say the proof of arc machining of a crust can be found in Folger's spinal and tourmaline, etc. Absolutely, but I will tell you, in my opinion, I think those are lightning strikes. I don't think that they created like the Grand Canyon. I think there's so many lightning strikes that, my goodness, a piece of land's got to be hit by lightning, almost every piece, especially in a arid place, all the time. So, but I'm not saying that. Yeah, I am totally willing to say that that's a very plausible theory, but I don't myself subscribe to it. The long path to understanding gravity. Yes, I saw that. And my question to the electric universe people again is that you are basing everything on electrical fields, and what are those? And then what are those made out of, and what are those made out of? Whereas in our model, we have a model for everything, so even electric field we cannot just treat as plus and minuses and attractions and repulsions. We have to give reasons why. Go watch Yonel Deneau. I'll put that there. He's Yonel Deneau, take a look at his underwater experiments, and you will see the inspiration for our model of how, and some other people too, of how electric fields actually, what they really are. So I'm doing that. I'm putting the, I make vids about surveying geodesics to help flat earthers out. Come on, Jesse, you know flat earthers. I got it from inside. I do have inside information. The flat earthers, none of them believe the earth is flat. They are doing what I call sort of a Harvard hoax to see how far they can take it. The flat earthers are in the exact same category as the crop circles. That is, people are doing this and perpetuating that idea to see how far they can go. So, yes, there's a new model by Don Scott for Brooklyn currents. Yeah, those are interesting things. Absolutely. We have our explanations as well. And again, when you base everything on electric, and you have to tell me what the field is and what attraction is and what charge is. And that's my only question to the electric universe people. Well, I just subbed to you. It's going to be taken by FE though. Let's see. Cool. Let me read of something else. You know, the moon. I put that there. But then there is useful work forever. Let me see here. That was. I'm not sure. I'm trying to follow some of this. Helps out in different ways. I think there's some accepting. It says both the electronic. I really enjoyed it. All helps to me think different way. I certain entertain without accepting or rejecting it in out hand. Absolutely. Can it be both based on rectangle? I'm going to come back to that statement, Lisa. If you're still here, I've lost a lot of people, huh? Maybe it's because I started. I gave different opinions about the electric universe. I'm sorry. I know that a lot of people on Jesse's group is Electric Universe. Again, guys, I love your work, and I love you guys working on it. I just have questions for them. And I asked some questions at a conference once, and they didn't like it. And I'm not criticizing again, but I think the whole thing is, with critical thinking, we should all be open to everything. And I absolutely watch and listen to their explanations. But if we go back, Lisa, to your question, can it be both based on gravity and electric? Depends on your model. In our model, it's all gravitation. It's not even gravitation. In our model, the entire universe is made up of colliding matter, particles. And every particle is made up of subparticles. That's our model, everything. And we can describe everything, including what people call electric fields, including electricity, including light, including gravity. So myself and my father would say it's all kinetic energy, everything to be described from that. We don't need that. In fact, electric fields and electricity and lightning and all those things can all be explained down deep as particles themselves. So the magnetic field around something is particle. Take a look at Yonel Deneu's underwater experiments, and you can see things acting just like magnets, and all they have are fields around them of water swirling. If the water goes together, they attract. If the water goes in different directions, they actually fight and are pulled apart. So down to 5. Yeah, I think my electric universe stuff may have made some people upset. I'm sorry. I'm not here to make fun or say that I'm right or wrong. Those are just my personal opinions. You make up your own mind. Okay? And so when I say what is an electric field, the reason is because in our model we actually say that. So I hope that helps explain. Long path to gravity, yes. I looked at their model. I watched the whole thing on Walt Thornhill's understanding of gravity. It's a lot of, it falls in the category of people who basically look at electrical causes for what they say is gravity. So totally interesting. All right. Sorry, I didn't mean to cause an issue. No. Absolutely, Jesse. I'm not upset with anybody. In fact, I don't want people to go away because we had a bunch of people coming in, but maybe I just don't want to blow people off. In fact, I have my big project to attract millions, and I know I say this, but I'm not really going to talk about it until we get our other websites ready, and then I will spring that upon you. I've got a Kickstarter program. I've got it almost all laid out, actually, the whole concept, and I pitched it to people. And one of the things that will be in it is going to be an episode of Electric Universe, and it will be very praiseworthy of the Electric Universe. And the reason I want to do that is because in this project that I have in mind, the idea is not to judge what people are saying, is to explain it to it. In fact, one of the things I would say is that my philosophy is that each one of us have sort of bent. Some people like the electrical field and that kind of stuff and charges and stuff, and they look at the world sort of that way, and they like that kind of model. I myself am more mechanical. And if it's the case, I can make a model that's even simpler than that, and all it is moving mass. Everything is moving mass, including like electric fields and lightning and electricity and light and gravity. Then if you go by the premise of the simplest model wins, I believe maybe ours is the simplest. But is it correct? That's I don't think any model is ever correct, but models can be better than others, and in some things, and worse than others. So I see we still have 5 people. We're at 10:30, so I've been going on actually for an hour and a half. I know Lisa is usually sleeping by now. I don't know if Proto-X is still here, but I appreciate you coming by. Muito obrigado, gente. Muito obrigado mesmo. I did something in Portuguese. You want to watch me in Portuguese, do an entire one of these in Portuguese? I thought I couldn't do it, and even my spiel in the beginning. Let's go look at my Andrea Cease unboxing. I did it in Portuguese. And there you can see me speaking in another tongue. Any questions here? Oh, I do see people typing some stuff in here. I think look at all sorts of things and keep an open mind about it all. Absolutely. Unlike mainstream, which claims that science is settled. Absolutely, which makes no sense even to me. Yep. And I'll tell you, Lisa, the reason I know we're in a paradigm shift, and that's where I talked about this book here. If you want to read a book and you are not into philosophy, then don't read this book. But if you can stand philosophy, this is a great book to read. And this book will tell you exactly why, even though most people probably won't get it, but I'm going to write an article on sciencewoke.org. I'm going to do that and the scientific revolutions. But the reason we have so many models and they're different is because we are not only in a paradigm shift, we're in the last stages of the paradigm shift. So that's pretty darn exciting. That means we are on the forefront of all that. So anyways, let me go back to the questions here if there's anything more. Lisa, I think much of the ideas meld together and all these people should be talking. Absolutely, Jesse. That's why we have the best I'm sorry, I will say this. Our group is better than the Electric Universe in the sense, and this is only in this sense. We're not better than the Electric Universe at marketing. We're not better at them in organizing their conferences and making great videos and really engaging their audience. They win. They beat us to a pulp. I'm working on it, though. We don't have as many people, but I applaud them. Oh, I don't have my sound effects because I'm on a different computer. But anyways, I applaud them greatly. So the reason ours, I think, is the best is because everyone gets a voice. And so because we're in a paradigm shift and we are retooling. I gave you a little bit of answer to it. That we absolutely have to keep open to all these, because it could be any one of these could be correct. And again, because I think of the particle model that we have, that we don't need the charge, and we don't need electric fields, and just saying that they're fields and not saying what they are, then I think our model is one step better. That's the only thing I would say. But you know what's funny is that a lot of the stuff that the electric universe talks about, our model can describe. And it can describe it physically. It just doesn't say positive and negative and they attract, or these fields do that and everything's electric, and then the nuclear. No, we tell you exactly physically what's going on, and it's all Newtonian. So again, the good thing is they're all together. Feel terrible about life and the trivia. Oh, cool. You do a live trivia show? That's pretty neat. You can even put trivia in here. What group of scientists are challenging all the mainstream? Can anyone name that? Have you heard about, there's Proto X. Have you heard about pilot wave theory of quantum mechanics? Yeah, I've heard it. I will talk about quantum mechanics, Proto X. The answer to the problem of quantum mechanics is that they have no model. Their models are really bad. They don't have a model, actually. And because of that, they're going to come up with this and that and the other. But they're going to beat around the bush, whereas we have several. Actually, there's an explanation, sort of like the dark matter, one of the really great minds in our group, Eric somebody, I believe, and he had a great talk in 2017. So if you go to Eric, buy the proceedings from 2017 at naturalphilosophy.org. Go there. Let's see here. Go naturalphilosophy.org, and you go to the proceedings. You can then go get them and read Eric's. Let's see if I don't have them listed. Conferences, proceedings. Yeah, if you go here and you go to the proceedings, you're going to see Eric somebody. Gosh darn it. I wonder if I can get this really big. Find Eric. Where are you, Eric? I'm not sure I have a picture of him, or if it was on there. Yeah, it was in Vancouver. But anyways, Eric comes up with a great explanation for some of the double slit stuff that doesn't need anything but regular physics. So the problem with quantum mechanics, the moment you get into the questions of, is it this idea, the pilot wave theory, or it's the Copenhagen quantum mechanics, or it's this or that, lost, and lost, because no model, no physical model for light and gravity, no physical model for light and gravity or anything else, no comprehensive physical model. And when you take our physics model, my dad and I, we can explain all of that stuff using Newton. So I'm sorry that's not exactly the answer, because I'm beating around the bush still. I am enjoying philosophy as of late. Good. Well, read the Structure of Scientific Revolutions. Okay. I've told people about it, and the word questions sometimes like, according to mainstream science, blah, blah, blah. Yeah. I know, Lisa, there are people that do the comparative mythology. I think that's really great stuff. I think some of the, I know Velikovsky says that Venus came in about 35,000 years ago and then got into orbit. I'd like to see calculations about the perturbations of all the planets and models done about that before I would believe that. Bode's law talks about where the planets are, and I believe they've been around longer and that they flew in. But I wasn't here 30,000 years ago, and I will tell you, I will never say never. So, absolutely, it's fascinating. There's stuff on ancient stuff, the petroglyphs and all that, and trying to find relationships. Critical thinkers that work. It's all valid. It's all open, and it's all open for everybody to interpret what they think is going on. The quirk of quarks is that they just don't matter. Ha ha, that's very good. You know, quirks were invented, folks. We used to discover stuff and then give it a name. Well, after a while, we just started saying, oh, if we have, this is the way it works. We have 4 things: water, earth, fire, air. Everything was made out of that. Then we found there was atoms, and there's about 100 and some atoms. Oh, and then all atoms are made of electron, proton, and neutrons. Well, in this case, now we think they're really only electrons and protons. Fine, doesn't matter. A couple particles. Oh, now those must be made of something else, and then they made them quarks. But then there were 6 of them, then there were 9 of them, there were 6 of them, they have magical powers. So how could you have 6 things with magical powers and say that they're the same? I don't understand it. So it all went to hell in a handbag. Oh man, yeah, the Thunderbolts projects, they have lots of great data they look at. One of the things I like about watching their stuff is looking at the data. Again, I have a harder time with their model, and they talk about their models because I think they're behind some of the models that we have. But that's okay. They were behind on the Einstein curve. But they have, the electric universe has absolutely great predictions. They predicted the flash that was going to happen on the, I think when they crashed the probe into the asteroid or whatever. That was cool. So they made great predictions. They predicted flashes when they hit Jupiter and all that. So that's cool. That's absolutely cool. But because we're working, I think, in my opinion, beyond that, I don't spend as much time as over there as I do. But keep up the great work, Electric Universe. Yeah, and if that's your thing, yeah. Let's see. I've asked others, and they explained about how there are some issues, but with it, but it's still just wild to me. Oh yeah, absolutely. I remember. I love Thunderbolts. Yep, you said that. Yep, I am sub to them now as well. Absolutely, I do. I'm subscribed to them as well. I'm subscribed to lots of people whose models, in the end, I don't actually think is the best model. But like Jeff Yeast, gosh, that is such a great model. But you know, he's got those magical particles at the bottom. But you know, it's still a great model. I love it. I love every video he makes, and I watch it, and you can learn so much from it. So really cool. The only thing I'm not really into is the how do you say, the UFO kind of stuff. Again, I'm just not into it. It's not my thing. That's all. Okay, we still have 6 people watching. That's really great. If you have any more questions, I think I'm going to pop off. I've been here almost 2 hours. Let's see. It says right here. Does it say how much? Yeah, 1 hour 43 minutes. If people saw my sub list, they thought I might be committed. Enjoying various things. Absolutely not. That's really cool. Nope. Absolutely different subs. Some people like Nick of Time. I love his stuff. I mean, not the best presentations in the sense of the format. I mean, his microphone isn't that good. It doesn't matter. His stuff is fascinating to me. So you just have to find your bent and who you like. Alrighty. I know it takes a minute or so. I'm watching me live, so you guys are. Let's see how much time. Here, I'm waving my hands. So it goes up and down. Absolutely, you're on for a couple hours. People see an announcement. Probably people who never saw this channel see an announcement. Most people who come to these are people who are subscribers. But I will tell you again. Yeah, Nick of Time's really cool. I love that guy. I got to get him on. I got to interview Nick of Time because he spent a decade fight in sending questions to the Einstein Institute in Germany, who by law, by German law, has to answer every question. And he painted them into a corner on relativity. And they couldn't get out of it, but they had to answer the questions. But they ended up sort of stopped answering him, even against the law. So that's a good one. Anyways, lots of great things. Let me see. I'll give you guys a look. I don't know. I think I showed you this before, but maybe some people haven't seen it. I'm going to log into it and give you a little. Hopefully I can. If I can't, then I'm lying to all of you. See, can I get in? Can I get in? Yes, I'm in. But I'm going to make so many changes on this, I'm not. Anyways, here's my science woke, university failing at education. I'm going to put another one in there. Variety is the engine for space. That's going to change. That's the variety is a sign that we're in a paradigm shift at a certain point of it, according to, and scientific society in the planet, the best scientific. Oh man, you can't see that. I think I got the wrong. Okay, become science woke. I think I've showed some of you this here. And this is really cool. This is what we're going to be selling people like you, Lisa, who are going to first come in, who want to be science woke. Our objective is to be science woke because we have our logo, of course. And we're the community of critical thinkers. And there's my little graphics. And our home is natural philosophy. It talks about what being science woke, some of the flaws in mainstream. It says that there are stuff, and we will see those. Of course, our website has those kinds of things. If I open it up just a little bit bigger, you're not going to see some of it, but you can see it pops in here. We have mainstream flaws. We have scientists, new theories. And they're really cool. I'll show you some of the scientists. Again, if you've seen this, pardon me, but if you haven't. So if you see this, you can go over here. And here's a cool one. Dr. Duncan Shaw, retired lawyer and Supreme Court Justice. That's who he is. A former Supreme Court Justice with his own physics theory. He does. I call it the Vancouver ether theory because he was inspired by the weather in Vancouver. Here's Ron Hatch, has 30 plus patents in GPS and says GPS reveals flaws in special relativity. My favorite scientist in the world, Dr. Glenn Borkert, replaces the Big Bang with an infinite universe. Award winner, unified the four forces in nature. Here's the expansion technology, and let's take a look at her. This is what we are working on, folks. Look at this. This is pretty cool. Come here, and I've got a little smaller so you can see it. Scientist profile, mind blown, female with PhD from MIT in physics and relativity, who is now a critic of relativity. She got her PhD in physics and relativity from MIT, a woman. She's now saying relativity is wrong. And tells about her story. Well, she fooled her parents and didn't apply to any other college other than MIT, and then she got accepted into it, which is amazing for a woman. And her parents says, "Why didn't you apply to the other ones? It's too late. I got to go there." And her parents didn't want to go there because women shouldn't go there, but she did anyway. It's a great story. And here's some books she's written. Oh, and here's some papers she's written. All of them in our database. From, do atoms really have states? Spectroscopy of relativity's keystone, Maxwell's maxim, a new theory for important new technologies, all kinds of stuff. Essentials on special relativity, Planck's constant, just an astronomy model with an infinite universe. Whoa. So it's pretty cool. Really cool. And this is a lady. So this is what we have here. And we're going to have articles that are easy to read in here. And you're going to be able to see mainstream flaws and those kinds of things. So that's a peek. Off. All right. So I'm going to get back here. Any more questions? Probably not. Thank you so much. And I appreciate it. Thank you, Jesse. Great work you do. I'm like you, spread it out there because you never know what's going to turn somebody's critical mind on. The electric universe turns a lot of people's minds on. Great for them. Keep up the great work, all those people working in that area. ProtoX, muito obrigado, cara. Foi grande prazer, Goiânia. Você tem fala inglês muito bem, cara. Mas muito, muito bom. E eu vou fazer as coisas do André Assis. Eu prometo, eu vou fazer, cara. Tá bom? Muito obrigado para você. Lisa, thank you so much. Keep up the great work. Subscribe to those different places. Take a look. Think on your own if that's your thing, Electric Universe, if something else is your thing. And hopefully, next time, I'm going to talk. I'm going to tease you. I'm going to start talking a lot more detail about the particle model. And I'll give you a teaser here, right here. I'm going to type it into, you go to http://cover.naturalphilosophy. Oh, no, sorry. cover.universehack.org, Kazar. And you go to that, and you will see our cover. In fact, I'll go there, and that will be the teaser. Take a look at it. There it is. Let me get it smaller. Read that. That's a pretty amazing cover. I spent 2 years working on this cover to get it. I'm not quite satisfied for the very top of it. Explaining the universe, entire universe, is using Newton's gravity. And it's gravity at all levels. Be careful. It's not gravity at this level because there's gravity at infinite levels. All phenomena travel at the speed of light and therefore can be treated as the same particle. Oh my goodness. Light, gravity, electricity, fire, lasers, magnetic fields, electric fields, electrons, atomic bonds, atomic polarity, refraction, reflection, and more. The model of the universe the rest of us have been waiting for. Of course, this is us trying to sell our book called Universe Hack 3. We have not been able to break this model yet. Every time we think we found something we can't explain, we can explain it. But again, this is just a model. I'm not here to say it's right, but it turns out my father and I are working on this. So I'm going to start talking a little bit about that. That'll be a lot of fun since it's Friday. And of course, I always take questions. Thank you so much, everybody. You guys take care. And I always say, stay critical, stay thinking. I'm David D. Hilster. I'm your science therapist trying to get you science woke. I hope you find something interesting in the dissonant science world because we're in the paradigm shift and we're actually in the later part of it. It's another thing I'll be talking about. Ciao for now, folks.